So to recap, we're talking about retirement plans, or in other words, deferred compensation. And there's two main types: defined contribution, right, which is, you know, you have a certain amount of money that you put in, but the benefit is not necessarily guaranteed, at least at a certain amount, right? The other one is the defined benefit plan. Well, the benefit, the amount of the benefit, depending on when you retire, is a guaranteed amount based on some formula, right? Like a pension, something like that. A little less common these days than they used to, but they're still out there. Vested, know what that means, right? You have to be employed in the plan for a certain number of years to be vested and be able to take advantage of this particular retirement plan. And it can either be a graded investment or cliff. We talked about that yesterday, right? Like if they say you're vested in the plan after 5 years, then boom, it's 5 years, 100% vested, right? Or maybe they spread it out over 10 years, but you get a certain percentage of investment until you get to, you know, year 10, and then you're 100%, you know, 70, 80, 90 years prior. Then a couple of simple, what were they? I think it was a pension or something like that, right? And a COLA, you know what a COLA is? It's COLA, living adjustment, right? Which is nice because we talk about retiring and still living after 30 years. It's really kind of a shame to keep living in one sense, you know, little glasses half empty kind of way. Yeah. Well, it's okay, he's still breathing, yeah, but you know, he's only pulling in 10,000 a year, you know. Inflation kills you, right? And by the way, what's our measure of inflation? What do we use? The CPI, Consumer Price Index, right? There's also a PPI, Producer Price Index, but for the inflation, what things cost us as compared to what they cost us yesterday, we use a Consumer Price Index. Get to example 3, right? We did that without a spreadsheet. So usually it's like some percent multiplier times some number of years that you've been employed in the plan, right? Or some average salary, whether it's your highest, say, 3 years of earnings or the final 3 years. Anyway, a lot of times it's one and the same, right? Because usually, but your final 3 years might not be your highest, right? Again, because maybe that last year of teaching, you only taught part-time, you know, you got it.
It's not always 1.5%. Right?
No, that's just an example of what, right, yeah. It all varies.
Set down for you.
No, I mean, for this, yeah, for whatever the situation was, that was that plan's set percentage, right? Just like there's not a set price for, you know, pizza, right? Huh? Right, okay. So anyway, hope you understand those. Let's move on to example 4. The pension one, there's a slight little wrinkle to this. Example 4. Hey Jackson, why don't you read example 4 for us, sir, please?
Brian and Marina are married and each planning on retiring after 30 years of employment. Marina worked the entire 30 years for Lincoln Central Corporation. For the last 3 years, she has been making $110,000 per year. Brian has been making the same salary for the last 3 years at Lincoln Central, but has only been working there for 15 years. Prior to his current job, he worked for 15 years at a competitor and had a final average salary of $60,000. Both employers offered a defined benefit plan that calculated the annual pension as a product of the final 3-year average salary, the number of years of service, and a 2% multiplier. Calculate and compare Marina and Brian's annual pension upon retirement from Lincoln Central.
Okay, so she had one job and he was in 2 jobs, right? But I believe it said both of his jobs were using the same pension formula. So let's simplify things a little bit, right? Let's figure out what that formula is. Read back through there, right? And the pension formula just generally is what? So
Multiplier multiplied by average salary multiplied by average.
Right. And well, let's get a little more specific. Just average salary over your lifetime, or what was right? So the three-year average salary times,
Is that the highest?
what did it say in there? I think it was the final 3 years, yeah?
Yeah.
This was the final 3 years, yeah. Times what? What was the percent kicker multiplier? 2%, right? Times 2% times what? Number of service years. Ran out of room here. Wasn't that it? And you can put them in any order, of course, right? So we got two of them, right? Look, the simple one will be Marina, yeah? Let's do Marina's pension. All right. So her 3-year average salary was what? $110,000, right? And we're going to multiply that by what? 2%, so times 0.02. And then times the number of years. How long did she work? 30 years. Easy enough. And you push buttons on that, you should get 66,000. All right. So that's one of them there. And now let's do Brian. A little more complicated, but not too bad. Well, let me go down a little lower because I want to put a little heading in there. Brian. Okay, so he's going to have job 1, right? And job 2, right? So from his job 1, what are the numbers going in there? There's the formula.
60,000.
So 60,000, yeah. Times 15 years, right? And it's still 2% multiplier, right? Okay. And should be a plus in here. So now plus, the second job is what? How much? 110,000. And how many years with job 2? Was it 15 for both? Okay. And again, times 0.02. Push buttons, add those up, should get 51,000, right? It's not quite as complicated as they could be. All right. But I do want you to try to check on this. And I'd like you to, if you read that, set this up algebraically. You know, with like an X or something in it, right? Okay? So if you understand how this got set up, read the check and set up an algebraic solution for this. So any thoughts on the algebraic setup here? Shouldn't be too hard. You guys are all, yeah, Sheldon?
G times X plus 1.
What now?
G times X plus 1.
Yes.
Just replace the salary with X.
Is that what you were saying? Replace the salary in the job 1 with X? It sounds like what you were saying. Okay. Well, I'm trying to give him the benefit of the doubt. Okay. That's exactly what you were saying, right, Sean? So X times 15 times 0.02 plus job 2, it's still going to be 110 times 15 times 0.02. What do they want that to equal? 66. Oh, to be equal to hers. That's right. All right. So now you just go through, simplify it, get it solved. That tough now. That's going to be 0.3x, right? 0.3x plus 0.3 times 110,000. Does that give you? Anybody? 33,000? Seems like it. Gonna need to equal 66,000. Subtract that 33,000.
You know, that makes a lot of sense.
What's that?
The answer.
Yeah.
In
Doesn't it?
hindsight, it makes it, yeah, that makes sense.
Yeah. It will, won't it?
It really does.
It was, so it comes out to,
110,000.
he would need to have made 110,000. Well, that makes sense, right? Because maybe, like, but even if you're thinking of it algebraically, if we just had this, and couldn't you factor out the 15 and the 0.02? And what's left inside has got to be 110,000. Does that make some sense? Or if you factor out 100, I guess, yeah, either way, some way like that. All right. Okay, one more example. Why? Read that example 5 there, my man. This is this looks like a graded vesting. Oh boy.
This is where the pension plan will calculate the annual pension of the product of the final 3-year average salary, the number of years of service, and a 2% multiplier. Her employer uses a graded 6-year vesting formula that is shown. After 5 years, they decide to leave her job. Her average salary was $50,000. How long pension will she receive?
Okay, so do you see the little table there to the right? Good talk, kids.
I see it.
All right. Would you nod your head while it's turned away?
Yeah.
All right. That makes some sense. So she left after 5 years. So whatever her pension formula gives her, given that she left after 5 years, what are we going to multiply it by?
80.
Yeah.
Or 0.8, right?
0.8, right? So really there's a 5-year formula. It's going to include a 0.8, right? So was it 50,000?
Yeah.
And what are the numbers we multiply by? How many years? 5 times 0.02 times the 0.8, right? She's only getting 80% of whatever that formula gives, right? And then you push buttons on that, it's 4,000 per year. Ouch. I hope she's got some other irons in the fire.
That's a big option.
Yeah. Yep. I have to, maybe get involved in some of the darker trades, something underground, black market kind of. But, oh, you said it, I didn't. All right. So do the check now. And notice that they say after a certain number of years, right? Like, let's say, listen, guys, if you read this as she left at year 5, would you be using 5? You'd be using 4, wouldn't you? Right? The way we count time, we refer to it. So that's why the end of the millennium is not on December 31st, 1999. 2000. You had to finish the 2000th year.
When is the 21st century?
We are currently in it.
When did that?
It's right now, Paul.
When?
No.
December 30th.
Oh,
December
okay.
31st, 2000.
So sorry, so like 22nd.
Well, actually, it began January 1st, 2001.
All right. Yeah, that makes sense. So the 22nd century wouldn't be until,
Won't be for another 70.
oh, okay.
Yeah.
Got
So a lot of people, everyone made them, even smart people, like 1999 was the last year of the millennium. No. Is 99 the last year of a century? How many years in a century? 100. You gotta finish it first, right? Just because the digit changes doesn't mean you move it. Anyway, do the check. That's one of my things. I thought I was over that rag like 20-some years ago. Nobody would listen to me. I'm so right. Do the check. Unimportant consequence of her day.
I have no idea where you
The aggregate.
get that notion.
So 38,500. Use commas when you're doing finance, by the way. Right? It's traditional. It keeps things clear. Yeah. Times 4. Yeah, poor Casper is going to be using commas when the cows come home. And 60%, right? Because that's the every year.
I'm not even doing numbers, just comments.
That's per year. I better indicate up here that's also per year. That's pretty thin, man. It's like, why bother? That does not even rise up to being called a nice gesture. You know, it doesn't rise to that level.
You could probably barely live off that per month, let alone for a year.
Yeah, yeah. What's that? You were doing some figuring over that?
It's like not much money.
So you did, wait. Look at this thing. So you're all the way back there, your calculator's smoking, you're pushing all these buttons, and your conclusion from all that calculating was, that's just like not much money. What was the point of all that calculating?
I pressed like 3 buttons.
Beat boop boop.
All right.